Hello, hello, hello. I've done quite a few updates since the last video. I'm going to start with numbers, which may be a little bit boring for some, and then I'll move on to some of the more visual updates. Um, so one of the things I did is I wrote some assembly code to speed up the matrix multiplication. So if we run, I have a few benchmarks here to show previous the previous performance versus the new performance for these matrices. So you'll see here that the matrix multiply has gone from roughly, in this case, about 60 nanoseconds per operation to 20. So that's about a third cut down on that. The matrix multiplication against the vector 4 has been dramatically cut from almost the same amount as matrix to matrix to 8 nanoseconds. So that, I don't know, you do the math, that's pretty big. And then the largest one is the vector 4 matrix multiplication against the vector 4 to matrix multiplication. That one is half of it's or twice the speed of the other one, and that's just because how the assembly code has to be written. The matrix has to be transformed into column space, and so it's going to be slower than this one. Since it has to be transformed into column space, it's going to be slower than this one, which doesn't have to do any transformations, and it can just pipe straight into SIMD. If you don't know, that's single instruction, multiple data, allows us to run math operations very fast. So the matrices are incredibly fast now. That's the more, for those of you who are technical, that's some more technical changes that have come across. So now we can jump into some more of the visual stuff. Oh, hold on. I was messing around with some things and that happens. So same as usual, I'm going to create this test project. This folder doesn't exist, so it just got generated. Um, and pretty much all this stuff looks the same. We have the hierarchy. We have the content window. When you open the content window, the search box is automatically selected, so you can just immediately go to type. We have the log window still all there and looking good. And the new one is the details window, which is when you select an entity. Oh, ignore that flashing on the left. I've just got to clean the UI when this gets refreshed. So these are actual fields that do work. So you can type in here whatever numbers you want. 5, 5. That's a very small amount. Let's do 35, 35. 40, 35. Oh, that's huge. 5. So, oops. All these fields are set up to work. Let me just change this all back. Okay. Um, so that's what happens when you can select object, and the name changes well works. Monkey. You'll see it gets updated here as well. So this is the details window. Now the major update that is data binding. So data binding is the way you can attach structures to this object from your source code outside of the editor and have it execute. So I can go over how that works right now. First, I'm going to save my map here as fancy, and what I'm going to do is I'm going to open up that project. I guess I didn't need to close the editor. Okay, so I open up that project, and you'll notice there's a workspace here now, so you don't have to see all the engine code. If you just want to focus on your code, you can open this workspace. If you do want the engine code, you can open up the other workspace that's up a couple folders. So let's say that I wanted to make some code to make this monkey move around on the screen. Now everything's in Go. There's no scripting language in this engine. Scripting languages are incredibly intrusive and slow down a lot. So the design is to try and avoid it. So I'm going to make one called a move up. All right, I just call it move. Move. I guess it could go up or down depending on what we're going to put in. You'll see. I'll just call it move around. Okay, let's make a move.go package move around. And what I want here is to create a structure, just the standard way. I'm just say move struct speed matrix dot float. This is just the built-in, if you spell matrix right, this is the built-in math code. And so we have this matrix float. I'm going to have the entity in here as well. Entity engine.entity. Okay. And now I want to implement the interface for this structure, because if I don't implement the interface, it won't show up inside of the data listing. So I'm going to say func mmove init, and the first argument is going to be the entity engine.entity. The second argument is going to be the host, host engine.host. And now you might be wondering, okay, so when this data loads up, how do I make the monkey move, right? So there's no such thing as update functions or anything like that, because half the things you build won't need update functions, and so I don't force you to implement some interface for everything. There's only one interface for data, and that is the init, and then you control everything from then on. So I can say m.entity is equal to e, so I can assign that value so I can use it. And then I'm going to create my function real quick. Doesn't need to be exported. Update, and it's going to be delta float 64. This is the time that it gets sent. I'm not going to code this part on screen because it's pretty straightforward, but what you could do is you do host dot updater, and this is it. This calls an update function on an arbitrary one every update. So I'm going to add the m.update into there, and that's going to make this function be called every update whenever it happens. Okay, so I quickly threw in the code here. This isn't a tutorial on how to write engine code or write code using the engine. But essentially, I just created a transform. I grabbed the transform of the entity, got its position, changed its position. I took its current position and modified it by the speed. This should be plus. So take the speed, delta time, and then move its position by that. So this is all our code. The key feature, or the key things to keep in mind is the init is this is the implementation of an interface that you need to have, and then you have your move. So I'm going to then register this move to be used by the engine. And so I can do engine.register entity data, and I'm going to just pass in a move pointer there so that it can register this move as part of the data binding system. From here, that's pretty much all you need to do. I need to do one extra thing here because of how Go works. Since that code is never referenced, it will be compiled out and not run at all. So we want to at least trick it into thinking it exists. Source slash, what do I call it? Move around. Okay, so now we've tricked it into thinking it exists. So now the init function will be executed. You wouldn't have to do that if you reference the code somewhere like outside of itself. Okay, so now that all that's set up, I'm going to just relaunch this editor real quick, just a moment. Okay, so we're gonna open up our stage here with our monkey, and then we're gonna add data, and this is a search here, so you'll notice move automatically shows up here. So you can search for your various data. I'm going to bind the move. You'll see that our move speed, that's our variable that we created. Actually, there should be a return line. It should say move and then a new line and then speed. So I'll fix that. But speed is related to this input box. So if I say I want to move by 0.5, that should move it up on the y-axis by 5. Of course, I got to save my stage again. And so I'm going to show you two features here, the data binding and also the debugging. So if I press F5 right now, it's actually going to go and compile our project. This is the first time compile. It's usually the slowest, but there you go. It's compiled. You'll notice that it opens our workspace here. Since we already had the window open, it just reopens the same thing. And what I want to do is I want to make sure I have attach to process here. Okay, so we can just press F5 to run it. And we'll see our monkey is moving up. So if we go back to the editor, we can make our monkey move down by just putting a minus in there and then resaving our stage and pressing F5. I should make F5 save the stage. I'll think about that. Come in here, press F5 to launch the process, and you'll see that the monkey is now moving down. So that's the process of binding data to our objects inside of the editor, and that allows you to basically bind whatever you want. And I'm going to have it so that these fields will be automatic. Currently, inputs only show up for strings and numbers, but checkboxes and things like that will also be showing up in the near future. Let's see, ignore this error. This is just a TCP error because when we connect the debugger to a Visual Studio running instance, we communicate logs over TCP from the client, just because the Delve debugger is in the middle between the editor and the runtime. Cool. So that's the major features that have been added. If you're curious about how this works, how we grab that data and show this stuff up, yes, some reflection is involved in order to reflect those types. Essentially, those types don't exist in the engine. So we use the GoAST. I use the GoAST to grab the code from your project and convert it around to be reflected into the engine so that it shows up and there's that binding, and it does do that check for what the interface implementation. One caveat right now to note is that when you create structures, it should be basically plain old data, just using types that are built into the engine and types that you write here instead of the source. It's not really going to go and, if this was some crazy package from the internet somewhere, it's not going to go and decompose that entire structure and figure that out. In fact, there's going to be an error if you do that. So you'll want to do plain old data. If you need to use that expressive extra data that's crazy, you should use plain old data objects to pump in the primary information, and then you can transfer that to the more complex structure. But that's just how that works for now. So this allows us to have Go from top to bottom, no scripting languages or no interpreters or anything. I'm actually going to delete the interpreter code that we previously had. I don't need it. So yeah, if you have any questions, let me know. Feel free to join us on Discord, check out the repository. I do live updates about what I'm doing and some of the different things that I do on Twitter if you want to follow me on there. So just, yeah, let me know if you have any feedback or any suggestions. Thanks for watching. I'll see you soon.